Ever think about cryptography as like a secret weapon against cyber threats, you know?
Yeah.
We're not just talking about encrypting data, it's bigger than that.
Right.
It's how it can actually defend against, well, like malware and denial of service attacks.
Uh-huh.
So the source material today is this YouTube lecture, right, from this cybersecurity professor.
Okay.
He's a real AI enthusiast, actually.
Interesting.
Uses AI to summarize his lectures, even.
Oh, wow.
But we're going to zero in on how cryptography is used to fight these attacks, you know.
Takes sense.
This is especially relevant for you considering your whole interest in cybersecurity and, you know, its real-world applications and all that.
Definitely.
So let's kick things off with the three pillars of cybersecurity, right?
Sure.
Confidentiality, integrity, and availability.
The CIA triad.
Exactly. Malware and denial of service attacks, they each target a specific pillar.
Uh-huh.
Any idea which ones?
Well, it's interesting how these attacks really exploit different weaknesses, right?
Yeah.
Denial of service attacks.
Yeah.
Those primarily target availability.
Okay.
They basically overwhelm a server with traffic.
Yeah.
So legitimate users can't access it.
I see.
It's like, imagine a restaurant
Okay.
gets flooded with reservation calls, but no one actually shows up,
Right.
and then real customers can't dine.
That's a great analogy. Now, the professor in the video, he talked about this classic technique, the SYN flood,
Oh, yeah.
where attackers exploit the TCP handshake process.
Right.
Could you walk us through that?
Sure. Imagine the TCP handshake as like a three-way conversation
Okay.
to establish a connection.
Right.
So the attacker floods the server with initial connection requests, but never completes the handshake.
So it's like a fake call, basically.
Exactly. The server sets aside resources for each request, but with no confirmation, its resources get exhausted,
Oh, I see.
and then it can't handle real traffic.
So it's like tying up all the phone lines at a call center.
Yeah, exactly.
So no one can get through. It's fascinating how SYN cookies use hashing to defend against this.
Yeah, pretty clever.
Instead of storing tons of data, it uses this clever trick with hashing to validate connections.
Right.
Can you break that down for us?
Absolutely. So instead of storing all the connection details, right,
Yeah.
the server creates this special cookie value.
Okay.
It does that by hashing key connection information with a secret number. And this cookie is sent back to the client.
Okay.
Now, if the client's legit, their response lets the server reconstruct the cookie
Right.
and validate the connection
Gotcha.
without needing to store everything.
So instead of remembering every single detail, the server just needs to check this cookie.
Precisely.
It's really amazing how this clever use of cryptography can really make a difference.
Yeah, it's powerful.
Let's shift gears a bit.
Okay.
Explain malware for a bit.
Sure.
The professor did this live demo coding a simple virus in Python.
Oh.
What stood out was how it targeted files with a specific extension.
Interesting.
Can you walk us through how a basic computer virus spreads?
Okay. So a simple virus, it usually attaches itself to a program.
Okay.
And when that program runs, the virus code runs too.
Right.
Then it starts looking for other files to infect,
Uh-huh.
often targeting specific file types.
I see.
It injects a copy of its own code into the file,
Oh.
infecting it.
Yeah.
When that infected file runs, the cycle just repeats.
So it's like a chain reaction.
Yeah, exactly.
Spreading from one file to the next.
Right.
Now, the professor also mentioned that basic antivirus scanners use hashing for malware detection.
Yeah.
How does that work?
Think of hashing as creating a unique digital fingerprint for a file.
Okay.
Basic antivirus scanners have a database of these fingerprints from known malware.
Uh-huh.
When they scan your computer, they calculate the fingerprint for each file.
Right.
If there's a match, it probably means the file's infected.
That's a pretty clever system.
Yeah, it's effective.
But then he introduced this thing called the polymorphic virus,
Ah, yes.
which changes its code every time it replicates.
Right.
It sounds like that throws a wrench in the system.
It makes it much harder to detect.
How does that work?
A polymorphic virus, it's like a master of disguise.
Okay.
It changes its code a little with each replication.
Oh, wow.
So its digital fingerprint's always different,
I see.
making it tough for traditional antivirus scanners to detect.
So it's like the virus is constantly changing its clothes
Exactly.
to avoid being recognized.
Precisely.
That's incredible. It's like a constant arms race.
It really is.
The professor hinted at dynamic analysis as a possible solution,
Right.
but he ran out of time.
Oh, too bad.
This seems like a good place to pause for now.
Sure. So these polymorphic viruses are really fascinating.
Yeah.
They force us to go beyond just comparing fingerprints. We got to look at the behavior of a program, see what it actually does when it runs.
So instead of just glancing at the cover, we need to read a few pages to get the story.
Exactly. Dynamic analysis, it observes a program's behavior in a controlled environment, like a sandbox.
Okay.
Does it try to say, change system files,
Right.
connect to suspicious websites? These actions can give away malicious intent.
The professor, he mentioned sandboxes, but didn't really explain.
Right.
How does that work? It sounds kind of like setting a trap.
Yeah, it is a bit like a trap. A sandbox is this isolated environment, like a miniature computer within your computer.
Okay.
So suspicious files run in this sandbox.
Right.
And we can monitor their actions.
Gotcha.
If the program tries anything shady, like deleting files
Yeah.
or connecting to a known bad server, we can flag it.
Okay.
Stop it before any real harm is done.
So we let the virus think it's in control,
Right.
but we're secretly watching its every move?
Exactly.
Pretty clever.
Yeah,
This sounds like it takes a lot of resources, though.
it's true. Dynamic analysis, it could take a lot of computing power and time.
Right.
Since you're actually running this suspicious code,
I see.
it's a trade-off,
Yeah.
between security and performance. But with these threats, like polymorphic viruses,
Right.
becoming more common,
Yeah.
it's a really important tool.
It's fascinating how these different ideas from cryptography and computer science, they come together
Yeah.
to make these layered defenses.
Right.
Like building a digital fortress with all these different kinds of defenses.
Exactly.
But is there any way to like predict or stay ahead of these evolving threats?
That's the million-dollar question in cybersecurity.
Right.
Predicting the future of malware, it's tough.
Yeah.
But AI and machine learning, they show a lot of promise.
AI for fighting malware. That's interesting. How does that work?
Researchers are training these AI models
Okay.
on huge data sets of known malware.
Teaching them to spot patterns and characteristics of malicious code.
Gotcha.
These AI systems, they can analyze, like code structure,
Right.
what functions it calls, even behavioral patterns to spot threats.
So we're giving the antivirus a brain boost,
Exactly.
letting it learn and adapt.
Precisely. AI helps automate threat detection,
Okay.
makes it faster and more efficient.
Uh-huh.
It can spot these subtle patterns, too,
Right.
that traditional methods miss,
Gotcha.
allowing for a more proactive approach to security.
That's fascinating. But I imagine AI could be used for bad, too.
Definitely a concern.
Couldn't attackers use it to make, like, even more sophisticated malware?
Absolutely. It's a two-way street. The same AI techniques that protect us
Right.
can also be used by attackers.
It's a constant race, then.
It really is.
Both sides trying to outsmart each other.
Yeah. A constant cat and mouse game.
Sounds like cybersecurity is this never-ending cycle of learning and adapting.
Right.
We need to be constantly developing new techniques.
Yeah.
To counter new attacks.
It's a battle that never ends.
Absolutely. Security, it's not a destination.
True.
It's a journey.
Right. Stay informed, being aware of new threats,
Uh-huh.
and using strong security measures are crucial for protecting our digital lives.
Well said. The professor in the lecture, he focused on using cryptography to detect threats.
Right.
But he briefly mentioned using it for prevention, too.
Oh, interesting.
He talked about something called code signing.
Okay.
Can you tell us more about that?
Sure. Code signing uses digital signatures,
Okay.
which is a cryptographic concept
Right.
to verify the authenticity and integrity of software.
Okay.
It's like a digital seal of approval,
Gotcha.
assuring users the software comes from a trusted source
Uh-huh.
and hasn't been tampered with.
So it's like a digital certificate of authenticity.
Exactly. The developer uses their private key
Okay.
to create a signature for their code,
Right.
which is
Yeah.
attached to the software. When you download the software, your system uses the developer's public key
Uh-huh.
to verify the signature. If the signature is valid,
Yeah.
it means the software is genuinely from the claimed developer
Okay.
and hasn't been changed since it was signed.
Makes sense.
This helps prevent attackers from distributing malicious software disguised as the real deal.
That adds a whole new layer of trust. But how does this work practically?
Okay.
Can any developer just sign their code?
Well, to ensure trust, code signing usually involves trusted certificate authorities,
Okay.
or CAs.
Right.
These are organizations that verify developer identities and issue digital certificates that link their public keys to their identities.
Gotcha.
When a developer wants to sign their code, they get a certificate from a CA.
Right.
Your computer trusts the CA's root certificate,
Okay.
which is pre-installed. This chain of trust lets your system verify the developer certificate and, in turn, the code signature.
So it's like a digital passport, verified by a trusted authority. Makes sense. But wouldn't this be vulnerable if the CAs themselves were attacked?
You're right. That's a critical point. The entire system's security relies on the trustworthiness of the CAs. If a CA is compromised, attackers could issue fake certificates
Right.
to sign malicious code and trick users.
So the entire system hinges on the security practices of these CAs.
Precisely. CAs are prime targets for attackers.
Yeah.
They need strong security measures,
Right.
like strong authentication, secure key storage, and regular audits to stay safe and comply with security standards.
It seems like securing our digital world is this complex dance.
It is.
Of trust, cryptography, and vigilance at every level.
Well put. Cybersecurity is a shared responsibility. Software developers, security researchers,
Right.
CAs, and users all need to work together
Right.
and be vigilant.
We've covered a lot in this part of our deep dive.
We have.
We explored dynamic analysis for catching those polymorphic viruses and learned about code signing, which adds a layer of trust to downloads.
Exactly.
But before we wrap up part 2, there's one more thing I want to touch on.
Okay.
The professor mentioned using cryptography for securing network communications,
Right.
specifically through something called a VPN.
Ah, yes, VPNs.
Given your interest in online privacy and security,
Yeah.
I think this will be right up your alley.
Sounds good.
Let's explore the world of VPNs
Okay.
and see how cryptography protects our data as it travels across the internet. So VPNs, right? They're everywhere.
Yeah, they are.
Ads promise they'll, protect your privacy, keep you safe online. But I'll be honest, I've always been kind of fuzzy on how they actually work.
Right.
Can you, break down the magic behind VPNs for us?
Sure. The interesting thing about VPNs is they create this secure tunnel
Okay.
through the internet.
Yeah.
Imagine you're sending a letter,
Yeah.
a really confidential one, through the regular mail.
Right.
Anyone could intercept it, right?
Yeah.
A VPN is kind of like putting that letter in a special encrypted envelope and then sending it through a private courier service.
Okay.
That only delivers to the intended recipient.
So it's like a secret pathway for your data.
Exactly. When you connect to a VPN, your device, it makes this encrypted connection
Right.
to a VPN server.
Okay.
All your internet traffic, it goes through this encrypted tunnel.
I see.
Even if someone snoops on your data packets,
Yeah.
they can't read them because they're encrypted.
Ah, that makes sense.
It's like trying to read a book, but it's in a language you don't know.
Okay, so a VPN basically hides my online activity from prying eyes.
Pretty much. It gives you a good level of privacy by masking your IP address.
Right, my IP address. It's like my digital home
Exactly.
address. Right.
When you're on a VPN, your internet traffic
Yeah.
looks like it's coming from the VPN server's IP address,
Okay.
not your real location.
So I could be, I don't know, in a cafe in Rome. But to the internet, I'd look like I'm browsing from, say, a server in, I don't know, New York.
Exactly. And that's just one perk.
Oh, there's more.
It also boosts security, especially on public Wi-Fi.
Okay.
Those are often unsecured,
Yeah.
vulnerable to snooping.
Right.
By encrypting your traffic, a VPN protects your sensitive stuff.
Like passwords and things.
Passwords, financial info, browsing history. All that's protected from being snatched by bad guys.
This sounds pretty crucial, honestly, for anyone who cares about online privacy and security.
It is a valuable tool.
Are there any, downsides, though?
There are some things to consider. One is performance.
Okay.
Routing your traffic through a VPN server
Yeah.
can sometimes slow things down,
Right.
especially if the server's far away.
I see.
Another thing is trust.
Oh, right.
You're basically handing your data to the VPN provider.
Makes sense.
You got to choose a provider with a good track record
Yeah, someone you can trust.
for privacy and security.
So do your research.
Exactly.
Choose a provider that fits your needs and values.
Right.
It seems like with tech, there's always trade-off.
That's true. No perfect solution.
This deep dive has been, wow, really eye-opening.
Glad you found it helpful.
We learned how cryptography fights denial of service attacks, talked about catching those sneaky polymorphic viruses,
Right.
and explored the world of VPNs.
Yeah. How they keep us private online.
Connecting all this back to the big picture,
Yeah.
cryptography, it's like the backbone of our digital security.
Absolutely. It's everywhere.
Protecting our data, securing our communications.
It's like an invisible guardian.
It's amazing how these complex concepts, right, often seen as like abstract and technical,
Yeah.
they actually have this huge impact on our everyday lives.
It's true.
It's a good reminder that even though tech keeps advancing
Yeah.
at this crazy speed,
Uh-huh.
the core principles of cryptography,
Right.
they're still essential
They are.
for trust, privacy, security in this interconnected world of ours.
Couldn't agree more.
So as we wrap up this deep dive, here's a final thought for you.
Okay, I'm listening.
If cryptography is the foundation, right,
Mhm.
of digital security, what new challenges and opportunities,
Yeah.
will pop up as like quantum computing gets more advanced?
That's a big question.
Will our current systems hold up against like quantum algorithms? Or will we need completely new ways to secure our digital future?
Now that's something to ponder.
That's a question that'll keep security experts busy for years to come.
I'm sure it will.
The quest for secure and private digital interactions.
Right.
It's a journey. It never ends.
It's an ongoing evolution.
Thanks for joining us on this deep dive into the world of malware and
It
cryptography.
is a pleasure.
Until next time, stay curious, stay informed, and most importantly, stay secure.